Have you ever wanted to set sail into the open sea with the desire for marginal profits through legal trade? Have you ever wanted the desire for that game to run on an industry standard tech stack that isn't really built for actual games? Well, boy, have I got the project for you. This is Reango Shipping, a browser game where players buy and sell goods at harbors on a map in order to turn a profit. First, let me be clear, this isn't my best game. This isn't even a good game. I built Reango Shipping to showcase my skills in full-stack development using the Django REST framework with a React frontend. The user interface is handled by React, which receives information like prices and quantities and sends information like transactions to APIs. I used Django REST framework to handle APIs, perform game logic, and read and write the postgreSQL database. And then I deployed the postgreSQL database and Django on Railway and React on Vercel. The data that Django kept track of included the player, like their purse, ship type, quantity of goods, and login status. Then the harbors, like their name, location, good quantities, and market equilibrium, and the ships, the ship name that the player could use, including the hull space and the speed that affected the gameplay. Django handles the financial logic. First, harbors will produce or consume goods over time until they reach their market equilibrium using the tick harbor function. When a player attempts a transaction, the information is sent to the API endpoint, and handled transaction verifies if the transaction is valid. For example, whether or not the harbor or the player have enough goods, or if the player has enough money or hull space for the transaction. If the transaction is valid, Django performs the transaction by patching the models. I didn't know much about authentication, but I know it's sort of a huge thing in cybersecurity, so I thought I would try the bare minimum by using Django REST Framework's token authentication. Whenever a new user was created or an existing player logged in, the API would return the player information as well as that token for the player. This token was then stored in the front end and be used to authenticate valid calls to the API, like updating the player or harbor information. This way, you spite another player by buying all of the bread from Saltmere. That player can't just open up Postman, put in the backend API, and suddenly create a false transaction in your player's name. For React, app housed the entire page, and I used conditional rendering for the pages. I also created a React context API for the current player and the harbors. All the other components would need to retrieve and update either player information or harbor information. The contexts include the current state, as well as a refresh function to recall the information from the Django API. This is a lot more straightforward than adding a fetch API into every component to grab the information from the backend. It also prevented prop drilling, which I learned is sending the props of the player and harbor from the parent down a long line of children. So it was a lot more clear to use that context. The map component was the first I built out and was kind of an interesting part of the UI I had trouble with. React updates when there is a state change, and the changes are made asynchronously in a batch process. I coded the movement to use their last location plus the vector of direction times speed of the ship for each frame. Therefore, I needed an up-to-date current location every frame for there to be movement. If I relied on state for the current location of the ship, then the state may not update before the function fires, keeping the location state in an endless loop of being overwritten before it gets updated by the previous value. This is called stale closure. React references are mutable objects that don't prompt a refresh. This isn't a batch process like state. Therefore, I use that in the movement function. Each time the movement function would update the location reference based on the current value of the location, they would be able to run again next frame using their updated location value to calculate the next location. Pretty much determining the difference between a state value and a reference value within React. I got pretty frustrated by this, but I understand the importance of the difference. State is really focused on the UI, Anything that needs to be shown should be a state, so that if there is high traffic, the UI can update asynchronously. For internal logic like the movement calculations, these should run synchronously, building on top of each other in this loop. Although the location of the player should be rendered on the UI, it's okay if there is a few milliseconds of lag as the location state is updated to the location reference asynchronously. The harbor modal is where a lot of the real gameplay was going to occur, the actual transactions. Within the market tab, each row has its own component that I set for each of the goods of the game. The buttons contain the core API transaction calls, so I didn't want to hard code them into a single good and have to put 4 different calls for each good, so the component was really helpful for simplifying the code. When you click the button, the component checks what good it is assigned to, what quantity and transaction type it was associated with that button, and then populates those fields of the JSON to send to the API. When a successful response is received, refresh player is called, and all the quantities within the harbor modal are updated to reflect a successful transaction. Some of the biggest challenges included UI positioning, since I wanted the player to be centered while the map moved around them. Then just being aware of which div I placed the component into and what the HTML styling meant for each of the spaces. Deployment also took a fair bit of troubleshooting. This is the first time I actually deployed a website on the cloud, rather than just through local deployment or housing on GitHub pages. So it was a lot of iterations of learning how to set the environment variables and setting configurations to allow for authorized communication between the front end, back end, and setting up the virtual database. I also learned some of the benefits and frustrations of environment variables and virtual environments during the development. My desktop runs on Windows while my laptop runs on Ubuntu, so I just had to remember the different commands for activating my environment. It also made me realize the importance of updating the requirements regularly. I might be working on my desktop and install a new package to utilize some tool, then I pull the latest changes onto my laptop and it crashes because I didn't update the requirements. Setting up environment variables is essential for ensuring security so that you don't expose your API keys or your passwords to your GitHub, so you store them locally. It was just a little annoying to set it up on both of them, and then when I would switch branches, then it would get deleted, so just having to figure that out a little bit. If I would do this again, I would set up the pages of the front end to their own routes, rather than all the components rendering on a single address. This would have just seemed cleaner to me, and it would have been easier to test out some of the login validation, like going to the map address when you haven't logged in and you don't have the token authentication. Cybersecurity is not necessarily something I thought too much about, but it is obviously really important, so setting up criteria for the username and passwords would have been nice. And then I think going into more thought about where to keep the token information. Should I keep it on the front end? Should I have an authentication call every time there is an API call? Or should I keep it as a local state during someone's login? I also wish I had tried cloud deployment sooner to catch some of the mistakes I was making in my backend configuration. It's generally good to test out end case environments early on to understand the requirements of what you're building. That's something that I had learned for indie game development and what I found in this case as well. If you find this interesting, you can find the code on my GitHub page linked in the video description below. You can also find my other projects and more about me at my website, also linked below. Thank you.